Hello students, good morning. Today we are going to see the new lesson, that is solution. So first we are going to see the what is the introduction and types of solution and the how to expressing the concentration of the solution. Before going to that, first one is introduction. What is mean by solution? So in this introduction we are going to see that what is mean by solution. What is mean by solution? So already we have studied about the solution in lower classes. What is meant by solution? Solute plus solvent equal to solution. That is, we already know that, right? So here, that is what is meant by solution. That is, important chemicals play an important role in our daily life. So that is in the chemicals. Say for example, in a sugar solution. What is sugar solution? The water, the sugar is dissolved in that water, that is making a solution, that is called as sugar solution. All these chemicals are in different physical forms, that is solid, liquid, gases. Okay, suppose we are close to examine on their composition, we can find out that the most of the mixtures of the rarely pure substance. Say for example, that is homogeneous. What is mean by homogeneous? What is homogeneous? Homo means same solution. So that is physical state are same. Such homogeneous mixtures are called as solution. That is the homogeneous, the physical state are same. What is mean by physical state? So homogeneous means same. The physical states are same. The solute and the solvent are in the same phase. So that is, say for example, solute means, so that is liquid means this solute is also liquid. That is, solute is also liquid and solvent is also liquid. Okay, so that is called as same state. The physical states are the same. That is called as homogeneous. So next one is best example of solution is, that is seawater. What is mean by seawater? Seawater, mixture of all the minerals, so covers more than 70% of the earth's surface. Seawater contains 70% of earth's surface. That is, we cannot imagine in the life without the seawater. So that is, we cannot imagine the life without the seawater. It contains many dissolved solids, mostly sodium chloride. Sodium chloride is a salt, table salt, right? Sodium chloride, most of them contain sodium chloride in the seawater. Another important naturally occurring solutions in the air. So the first one is seawater, that is naturally occurring. First one is seawater. Second one is air. What is air? That atmospheric air. So what is homogeneous mixture containing? What are the atmospheric air? Nitrogen, oxygen, carbon dioxide, other trace gases, remaining gases. These are all the containing present in the atmosphere. Even solid material such as brass is a homogeneous mixture of copper and zinc. So this is the liquid. This is air, then this is gaseous state and the solid state. Say for example, brass. What is brass? Brass வந்து பித்தளைன்னு சொல்வாங்க இல்லையா? So is a homogeneous mixture of copper and zinc. Copper and zinc. Okay, so this is the another thing. This is the homogeneous example. So in the above example, the solutions are different physical state. That is liquid. So that is seawater. That is liquid. Gas means that is air, and solid means that is alloy. This is commonly it is called as alloy. Okay, what is mean by alloy? Alloy are the mixture of different components of the metals. Okay, so that is called as alloy. The one common property all the above is their homogeneity. What is mean by homogeneity? That is, the solute and the solvent are the same. That is, the gaseous mixture also, that is nitrogen, oxygen, carbon dioxide, all are present in the air. These are all homogeneous, all are in the gaseous state. But in the brass is also copper and zinc is forming a alloy. That is the making only metal. So that is all these things, everything is replied as the only thing. Answer is homogeneity. What is homogeneity? Is the implied uniform distribution of their constituents or components of throughout the mixture. In this chapter, we are going to learn about the solutions and their properties. In this chapter, we are going to learn about the solutions and their properties. First, we are going to, what is the mean by types of solution? Types of solution. What is the types of solution? First one is a homogeneous mixture of two or more substance consisting of the atom, ions or molecule. The compound it is present large amount in a homogeneous mixture is called, what is homogeneous mixture? Homogeneous mixture. So that is the small part is called as, suppose in a mixture containing small amount is called solute. The large amount present in the homogeneous mixture, that is called as solvent. That is, we are already studying the homogeneous mixture. Large amount present in that mixture, that is called as solvent. Small amount, that is called as solute. For example, a small amount of sodium chloride dissolved in water. Sodium chloride dissolved in water. Okay. Dissolved in water. A homogeneous solution is obtained. In this solution, that is Na plus ion and Cl minus ions are uniformly distributed in the water. Sodium chloride na konjondu table salt eduthu water la dissolve pannom appadina, that is separated as a Na plus ion and the Cl minus ion, that is uniformly distributed on water. Here water is a solvent. So here that is water is a solvent. Amount of water is more compared to the amount of sodium chloride present in this solution. So that is sodium chloride is a solute. The sodium chloride is solute. The water is a solvent. Okay, that is commonly used solutions are the solution in which a solid solute is dissolved in a liquid solvent. Again another one is, next one is solid solute is dissolved in a liquid solvent. Solid dissolved in liquid. Solid dissolved in liquid. So that is how the solute or the solvent can be any of the three states. So the solvent may be, this is solvent. Solvent may be exist in a three state. What are the three state? Solid, liquid and gases. Liquid and gases. So that is the liquid. The solid dissolved in the liquid, that is the one solution. That is the solvent may be solid, liquid or gases. If the water is used as a solvent, the resultant solution is called as a aqueous solution. Suppose இப்போ ஒரு solute எடுத்து waterல dissolve பண்ணோம், அந்த solutionக்கு பேர் என்ன? Aqueous solution. What is mean by aqueous solution? எந்த ஒரு soluteயும் waterல dissolve பண்ணா அதுக்கு பேர் என்னது? Aqueous solution. So that is, if solvent, example other than water is used, that is called as non-aqueous solution. Suppose organic solvent, say for example, what are the organic solvent? That is ether, benzene, carbon tetrachloride. Okay, so these are called the organic solvent. CCl4, carbon tetrachloride, that is called as organic solvent. Organic solvent. Other than water, if the solvents other than water is used, mean that is called as non-aqueous solution. What is aqueous solution? The solute dissolved in that water, mean that is called as aqueous solution. Other than water, that is dissolved in the organic solvent, ether, benzene and carbon tetrachloride, that is called as non-aqueous solution. So here, say for example, in your tabular column, they are giving one tabular column. Say for example here, that is the mixture. What are the state of the solution? Gaseous state, solid, liquid, gases. They are example. Gas, that is humid oxygen containing water. So that is gas and liquid. And the gas that is air mixture of nitrogen, oxygen and solid and gas. Solid mean camphor and nitrogen gas. So the solid la vandu alla enna irukku? Nitrogen gas vandu mix agi irukku. That is called as gaseous solution. And another one liquid solution. Solid liquid mean that is salt water. Sodium chloride vandu water la dissolve agudhu. Ethanol dissolve in water. So rendume liquid. Ethanol liquid, aduthathu water on liquid. So inge gas, carbon dioxide dissolve in water. So nama இதெல்லாம் எடுத்துக்கிறோம் இல்லையா, சோடா எடுத்துக்கிறோம் இல்லையா, அந்த சோடால கார்பனேட்டட் மிக்ஸ் ஆகியிருக்கு, கார்பன் டை கேஸ் வந்து மிக்ஸ் ஆகியிருக்கு, dissolve in the water. So that is called as carbonated water. Next one is solid solution. Solid solution, solid. So example அதான் நம்ம சொன்னோம் jewelry. So gold alloy. So இப்போ நம்ம நார்மலா 22 carat. So 22 carat is not a pure gold. So 20% gold, remaining 2% that is mixture of copper using the jewelry. So again another one is liquid solid, that is amalgam of potassium. So that is liquid used for the dental filling. Another one is gas and solid, solution of hydrogen in the palladium. So that is called as solid solution. These are the types of the example of the solution. Next one is how to expressing the concentration of the solution. So next we are going to see that is expressing the concentration of the solution. So in everyday life we come across the so many concentration solutions. Say for example antiseptic solution or the mouthwash or antiseptic solution or the household disinfectant. So these are the did you notice the concentration? So that is the ingredient present in the solution: mouthwash, disinfectant. So do you notice about that? So they express the concentration in the ingredient. That mouthwash solution containing 0.2% weight per volume. So that what is the meaning for that? So that is the solution containing 0.2%. So total volume la ivlo percentage வந்து இந்த solution இருக்கு. So that is chlorhexidine gluconate. Gluconate, that is the concentration commercially available. Hydrogen peroxide, that is 3% W weight per volume. So that is hydrogen peroxide, H2O2. So these are all the ingredients. Similarly, that the other terms such as ppm, the parts per million. What is ppm? Parts per million. Okay, so this is the another one. This is the express the TDS of water. So that is what is meant by TDS, total dilution of this solution. Total dilution of solution. Total எவ்வளோ dilution இருக்கு அது எப்படி measure பண்ணுவாங்க? ppm, parts per million. நம்ம இப்போ say for example time வந்து second. So that is the gram, kilogram. So இப்படி mass weight வந்து kilogram, gram. So இப்படி weight measure பண்ண அதே மாதிரி the total dilution of the solution. So எவ்வளோ dissolve ஆயிருக்கு அதை வந்து நம்ம எப்படி mention பண்ணுவோம்? ppm. And another one is molar, normality. These are the expression concentration of the solution. So வேற எப்படிலாம் நம்ம ஒரு concentration of the solution நம்ம எப்படி express பண்ணலாம் concentration? So அதனுடைய strength நம்ம வந்து mention பண்ணலாம். அடுத்தது mole, எவ்வளவு mole இருக்கு, அதனுடைய molarity, then normality. So these are all we can express in the concentration of the solution. So this is the amount of the solution present in the given quantity of solvent. So mainly நம்ம ஒரு solution concentration எடுத்துக்கிட்டோம்னா டோட்டலா இவ்வளவு இதுல எவ்வளவு solution present ஆயிருக்கு, எவ்வளவு concentration. So different way of expressing the concentration of the solution. So this is the concentration of the solution. We are expressing the different way. So let us learn with different concentration of terms to prepare the solution of the specific concentration. First we are going to see the what is mean by molarity. So molarity is equal to, molarity is expressed in small m. So what is molarity? Number of moles of solute dissolved by mass of solvent in kilogram. Dissolve of the mass of the solvent in kilogram. Okay, what is meant by molarity? So repeatedly asking question, all the expression in terms of concentration is very, very important. The 2 mark question, definitely 2 mark question coming from this chapter. So again another one is what is meant by molarity. All the definitions are very, very important. What is molarity? So this is the definition: number of moles of solute dissolved by mass of the solvent in kilogram. அப்படினா என்ன அர்த்தம்? molarity-னா எப்படி எக்ஸ்பிரஸ் பண்றோம்? எவ்வளவு மோல் solute வந்து எவ்வளவு மோல் எடுத்துக்கிறோம், எவ்வளவு கிலோகிராம் சால்வெண்ட்ல, ஒரு 1000 கிலோகிராம் சால்வெண்ட்ல எவ்வளவு டிசால்வ் ஆயிருக்கு solute, அதுதான் பேர் என்ன? That is molarity. So next one is what is mean by molality வேற. So then molality. So this is called as molality, Lity, molality. So number of moles of solute divided by mass of the solvent in kilogram. So what is mean by molarity? What is mean by molarity? Now the same thing, that is capital M, number of moles of solute dissolved by volume of solution in liter. Okay, so what is meant by molarity? What is the difference between molarity and molality? Molality is equal to number of moles of solute dissolved by mass of the solvent in kilogram. Appo what is meant by molarity? Number of moles of solute dissolved by volume of solution in liter. Okay, that is called as molarity. Another important one, what is meant by normality? Normality, how to express the normality? Capital N. Okay, so how to express the normality? Capital N. What is N? Number of gram equivalent of solute dissolved by number of gram equivalent of solute dissolved by volume of solution in liter. Volume of solution in liter. Okay, so what is normality? Very, very important normality. So what is meant by normality? Number of gram equivalent of solute dissolved by volume of solution in liter. Okay, so this is called as normality. What is meant by normality? Number of gram equivalent of solute dissolved by volume of solution in liter. Okay, so this is the another one. This is called as normality. So next one is what is meant by formality? What is meant by formality? Formality, it is number of formula weight of the solute divided by what is meant by formality? Number of formula weight. What is meant by formula weight? That is molecular weight. Formula weight of solute dissolved by volume of solution in liter. Volume of solution in liter. Okay, so this is called as formula weight. Next one is what is meant by mole fraction. Another one is very, very important. What is meant by mole fraction? What is meant by mole fraction? What is meant by mole fraction? So mole fraction, say for example, number of moles of component, number of, that is X, capital X. So number of moles of the component divided by total number of components present in the given mixture. Total number of moles of all the components present in the solution. So what is the meaning for that? Now we are considering, so how to explain this mole fraction? We are considering the mixture containing A and B. Okay, so considering the mixture containing, that is, let us consider mixture containing A and B. So that is the mixture. How to calculate the number of moles of the two component already given. Number of moles of component Na, number of moles of component Nb. So how to calculate Xa? That is number of mole fraction of A solution. How to calculate? So number of moles of the component divided by total number of component present in the solution. So இதில எத்தனை components இருக்கு? ரெண்டு components இருக்கு, A and B. So இப்போ Xa கண்டுபிடிக்கணும்னா number of moles of A solution divided by A and B நம்ம add பண்ணோம். அப்போ what is mean by Xb? Xb is equal to Nb divided by Xa Na plus Nb. Okay, so that is the கீழ இருக்குது same இருக்கும். So now we are adding what is Xa plus Xb is equal to Na plus Nb plus Nb divided by Na plus Nb, so equal to 1. So what is the meaning for that? So we concluded that, so number of mole fraction of any two components equal to always 1. So number of moles of any two components is always 1. So that is called as mole fraction. What is meant by mole fraction? Number of moles of the component divided by total number of moles of the component present in the given mixture. So that is, we are considered two mixture. That is number of moles of A and number of moles. எவ்வளோ moles நம்மளுக்கு தெரியும். What is Xa? Number of moles of A divided by total number of moles are present in the given solution. So we are adding the two components. So that is sum of any two mole fraction is equal to two components is equal to, that is called as is always 1. So next we are going to see that what is meant by mass percentage. Mass percentage. What is meant by mass percentage? So that is weight per weight. So that is the percentage. So mass of solute in gram divided by mass of solution in gram. Mass of solution in gram into 100. Okay, so what is meant by mass percentage? Mass of solute in gram divided by mass of solution in gram into 100. Okay, so this is the another one. This is called as mass percentage. So next we are going to see the what is meant by volume percentage. So that is volume per volume. So that is called as volume percentage. Volume percentage. What is meant by volume percentage? Is equal to percentage V by V. Okay, that is volume percentage. So what is meant by volume percentage? Volume of solute, volume of the solute divided by volume of solution. Volume of solution in ml. So this is solute is also in ml into 100. That is volume. நம்ம லிட்டர்னு சொல்லலாம் இல்லைனா ml சொல்லலாம். That is volume percentage. Next one is mass by volume percentage. Mass by volume percentage. Percentage mass weight. Mass வந்து weight divided by volume. Okay. So how to calculate? That is mass of the solute. Mass of the solute. Solute in gram divided by volume of solution in liter. Volume of solution in ml. Mass of the solute divided by volume into 100. Okay, percentage always is multiplied by 100. So next one is what's by parts per million. What is meant by parts per million? Parts per million. That is ppm. Parts per million. And already நான் சொன்னேன் ppm வச்சு நம்ம measure பண்ணலாம் the solubility of water. So total number of parts of all components. That is the ppm. What is ppm? Parts per million. How to measure number of parts of the component? Number of parts of component divided by total number of parts of all components into 100 into 10 power 6. Okay, into 10 power 6 equal to mass of the solute divided by mass of solution. Mass of solution into 10 power 6. Okay, this is called as parts per million. What is meant by parts per million? Number of parts of the component divided by total number of parts of all the component. That is, otherwise we can write mass of the solute divided by mass of solution into 10 power 6. So these all the 2 mark question, all are very very important. So the concentration of this solution is expressed in different unit. So this is the type of, that is the different types of measurement is applied. For example, so so how to express the concentration, different method we can calculate it. So in this expression of the concentration, we can easily calculate it, use for this titration. In this redox and the neutralization titration, the normality, mole fraction is always expressed in the calculate the partial pressure of the gases, and also the percentage unit of the active ingredient present in the therapeutic uses, and ppm is used to express the quantity of solute present in the small amount in the solution. These all the concentration in term, this expression can be used to measure the partial pressure of the gases, vapor pressure of the solution, and the mole fraction of the solution, and also the active, what are the ingredients, what are the active ingredient present in the therapeutic uses, and the ppm is used to express the quantity of the solute present in the small amount in the solution. So these are all the express the concentration of the solution. So next we are going to see the what is meant by standard solution, what is meant by working standard. So what is meant by standard solution? So what is standard solution is otherwise called as stock solution. What is meant by stock solution? A known weight of the solute. So it is all, suppose we are taking the 5 gram of the solute, dissolved solute. is accurately weighed 5 gram of the solute taken in the 100 ml flask. Okay, 100 ml round bottom flask. Round bottom flask. This is the more 100 ml. Okay, so this is the 100 ml flask. The 5 gram solute is dissolved, accurately weighed and dissolved in that solvent. Okay, so dissolved in water, so accurately made. So that is called as 100 ml. It's make up into 100 ml. That is called as standard solution. Standard solution. First we are taking the 5 gram of the solute and add small amount of water and dissolve it. After then up to this mark we can make up this solute and solvent. Okay, solvent here, that is water, make up it, that is called as standard solution. So this is the accurately known weight of, that is the known weight of the solute. After then what is meant by working standard? From this stock solution, this is otherwise called as stock solution or stock solution. So from this stock solution we are taken 2 gram. So that is the 100 ml. இப்போ 2 gram அப்படின்னு சொன்னா 2 ml. So இதில இருந்து 2 ml எடுத்துட்டு we are making into again 100 ml. So the 2 ml is dissolved into another 100 ml. So that is called as working standard. What is working standard? Standard solution ஒரு 5 gram solute known weight எடுத்துட்டு அதில் நம்ம water dissolve பண்ணி 100 ml க்கு மேக்கப் பண்ணிட்டு that is called as stock solution or standard solution. இப்போ அதுக்கு அப்புறம் என்ன பண்றோம், இதில இருந்து ஒரு 2 ml எடுத்து இந்த இத 100 ml க்கு திருப்பி வாட்டர் போட்டு மேக்கப் பண்ணிட்டு இதில எவ்வளவு at the time of experiment அதனுடைய concentration எவ்வளவு இருக்கு நம்ம கால்குலேட் பண்றோம். The stock solution, the dilute solution is usually called working standard. So இந்த dilute solution இதுக்கு பேர் தான் என்னது, working standard. Working standard. A known volume of stock solution is transferred. This is the known volume of stock solution is transferred to a new container and brought to the calculated volume. So that is the necessary volume of the stock solution and the final volume can be calculated using the expression that is called as standard. CSVS, concentration and the volume. Stock solution is equal to concentration of this that is weight, volume, concentration and the volume. So where the standard solution and the working standard. W means working standard, S means that is stock. Stock are the standard solution, where CS, CV, VS are the concentration of the volume of the stock solution. This is concentration and volume of the working standard. Okay, so these are the standard solution. What are the advantages of this using the standard solution? So why we are using, first we are preparing the standard solution, அதிலிருந்து நம்ம எடுத்து working standard prepare பண்றோம். So what is the purpose we are using that one? That is the error due to weighing that solute can be minimized by using the concentrated stock solution that require large quantity of this solute. What is the meaning for that? இப்போ நம்ம weigh பண்ணும்போது accurate-ஆ weigh பண்ணணும். Suppose அதுல weighingல inaccurate இருந்தா கூட அந்த error will be minimized after preparing the working standard. We can preparing the working standard of different concentration by diluting the stock solution, which is more efficient since consistency is maintained. So here that is now from this stock solution we are different concentration we can prepare. We can easily prepare from the different concentration. இப்போ நம்ம இதுல 2 ml எடுத்துக்கிறோம், அடுத்த next வந்து ஒரு 5 ml எடுத்து இன்னொரு solution working standard. So அப்போதான் நம்ம அதனுடைய consistency நம்ம வந்து calculate பண்ண முடியும். That is the result will be more efficient. And another one is some of the concentrated solutions are more stable and are less likely to support microbial growth than working standard used in the experiment. So concentration solution நம்ம யூஸ் பண்ணும்போது என்ன பண்றோம், மைக்ரோபியல் growthக்கு வந்து சப்போர்ட் பண்ணும். So working standard பண்ணும்போது அப்படி பண்ணாது. So that is the another uses, advantages. What are the advantages? So that is the error due to weighing the, so during the accurately weighing, so the error will be minimized for preparing the working standard. Another one is working standard, different concentration we can able to prepare for the different concentration. And another one is some of the concentrated solutions are more stable than the less likely to support microbial growth than the working standard used in the experiment. Okay, that's all about this working standard. Next we are going to see the what is the solubility of the solute. What is meant by solubility? The solubility of the solute, the maximum amount of solute that can be dissolved in the solvent that is specified at specified temperature, that is called as solubility of solute. So that is the maximum amount of solute maximum amount of solute dissolve in maximum amount of solvent at specified temperature. At specified temperature, that is called as temperature, that is called the solubility of the solute. The maximum amount of solute in a solvent, that is addition of solute, will result in the precipitation in a given temperature. So that is maximum amount. After that maximum amount, we are adding that solute, mean that is precipitation will be occur. Such solution is called the saturated solution. What is meant by saturated solution? Saturated solution in organic compound, what is meant by saturated? Saturated means single compound, but here in the what is meant by saturated solution, no more will be added, that is complete. The precipitation will be occur at a given temperature, that is defined as the amount of solute that can be dissolved in the 100 gram of the solvent in a given temperature to form a saturated solution. What is meant by saturated solution? That is the amount of solute that can be dissolved in 100 gram of the solvent in the given temperature, that is called as saturated solution. What are the factors influencing the solubility? What are the factors influencing the solubility? That is the solubility, that is nature of the solute and the solvent. First point is nature of the solute and solvent. What is nature of the solute and the solvent? First we are going to say, for example, sodium chloride. Sodium chloride is an ionic compound. Okay, so ionic compound is a easily dissolved in the water. That is the polar compound. Polar solvent. Say for example, but this sodium chloride not dissolve insoluble in non-polar solvent. What is non-polar solvent? That is organic solvent. Non-polar solvent na water illada solution. So that is called as non-polar solvent. Insoluble in non-polar solvent. So another one is such as, what is non-polar solvent? Benzene, ether, carbon tetrachloride, benzene, ether and CCl4. These are the non-polar solvent, but they, that is depends upon the nature of the solute and the solvent. So here that is sodium chloride is the ionic compound dissolved only in the polar solvent, but it is insoluble in non-polar solvent. This is the nature of the another one. Many organic compounds are dissolved in the organic solvent. Organic compound dissolved in the non-polar solvent but does not dissolve in the water. Different dissolve in water to different. Example, ammonia is more soluble than oxygen in water. Ammonia வந்து easier water dissolve agum than oxygen. Okay, so this is another one is effect. This is the first one. Next one is, what is the effect of temperature? What is mean by effect of temperature? What is mean by effect of temperature? First one is solid solute in liquid solvent. Solid solute in the liquid solvent. So here that is the solubility of the solid solute, that increases with increase in the temperature. So the solubility, so இப்போ ஒரு solute வந்து நம்ம add பண்றோம் ஒரு solventல, அப்போ temperature increase ஆச்சு அப்படினா the solubility வந்து எப்படி இருக்கும்? குயிக்கா இருக்கும். So that is the temperature will be increased, the solubility is also increased. The average kinetic energy of the molecule of the solute and the solvent increases. The increased kinetic energy, that is solvent to break the intermolecular attractive forces. Increase the kinetic energy, so that is the intermolecular forces are intermolecular forces. Intermolecular forces that keep the solute molecules together, hence the solubility increases. Okay, so that is the reason the temperature is increases, automatically the solubility is also increases. Again, one is when a solid is added in a solvent, it begins to dissolve. When the solute leaves from the solid state, that is dissolution, after some time some of the dissolved solute return back to the solid state, recrystallization, that is excess of solid present. The rate of both these process equal to the at a particular state, that is called as equilibrium. So what is mean by equilibrium? That is called as solute equilibrium into solute dissolved. Dissolved, this is solid. So what is the meaning for that? இப்போ நம்ம என்ன பண்ணுறோம், ஒரு கொஞ்சம் வாட்டரில் எடுத்துட்டு கொஞ்சம் சுகர் ஆட் பண்ணிகிட்டே இருக்கோம். இல்லை எக்ஸாம்பிள் சால்ட் சோடியம் குளோரைடை ஆட் பண்ணிகிட்ருக்கோம். என்ன பண்ணோம், கொஞ்ச நேரம் இப்போ 100 ml வாட்டர் எடுத்துருக்குறோம், ஒரு 10 கிராம் சுகர் இது சால்ட் ஆட் பண்ணியாச்சு, டிசால்வ் ஆகிட்டே இருக்குது. கொஞ்ச நேரம் ஒரு 50 கிராம் ஆட் பண்ணியாச்சு, 100 கிராம் ஆட் பண்ணியாச்சு, 200 கிராம் ஆட் பண்ணும்போது என்ன ஆகும், அதுக்கு மேலே அங்கே டிசால்வ் ஆகாது. அப்போ அது சொல்யூஷன் பேர் என்ன, தட் இஸ் சேச்சுரேட்டட் சொல்யூஷன். ஆஃப்டர் தென் இட் வில் சொல்யூட் வந்து டிசால்வ். ஸோ அது என்ன ஆகும், மறுபடியும் இட் வில் precipitate ஆக ஆரம்பிச்சிடும். அப்புறம் என்ன ஆகும், ரீகிறிஸ்டலைட் ஆகிட்டு மறுபடியும் இட் வில் கம் பேக் டு த சாலிட் ஸ்டேட். அட் திஸ் ஸ்டேட் that is called as என்ன சொல்றோம், that is called as equilibrium. What is meant by equilibrium is established between the solid solute and the dissolved solute molecule according to the Lee-Chatelet principle. What is meant by Lee-Chatelet principle? That is dissolution process endothermic. That is the what is meant by if the stress is applied, ஏதோ ஒரு ஸ்ட்ரெஸ் வந்து the direction of the reaction change பண்ணுச்சு அப்படின்னா the shift the equilibrium towards the solubility increases. So இதை மெயின்டைன் பண்ணுறதுக்காக, இந்த equilibrium மெயின்டைன் பண்ணுறதுக்காக அந்த டைரக்ஷனில் அந்த ரியாக்ஷன் நடக்கும். that is called as Lee-Chatelet principle. 9th லெசனில் Lee-Chatelet principle படிச்சோம். So that is the Lee-Chatelet principle. According to that, the temperature will be increases means that is the according to that the reaction will be go to that direction. Increase the temperature, decrease the solubility. The solubility of the ammonium nitrate, calcium chloride, that is they given one example. They given the one flow chart here. That is one flow chart here. That is comparing the ammonium nitrate, calcium chloride, sodium chloride. Sodium chloride is easily dissolved, so that is saturated. The solubility will be increases. So that is the ammonium nitrate and sodium chloride water at the different temperature. This is the plot of the solubility versus temperature for selective compound. So இங்க temperature நம்ம increase ஆகாக அதனுடைய solubility எப்படி இருக்கும் அப்படின்னு சொல்லிட்டு they given on the flow chart. So what is the reason for that? The following conclusion. So இந்த கிராஃப்ல இருந்து நம்ம என்ன தெரியும், the solubility of sodium chloride does not vary. So the sodium chloride நமக்கு எந்த variation கிடையாது. What is the reason? Because there is only 10% increase in the solubility between 0 to 100 degree. 0 to 100 degreeக்குள்ள எவ்வளவு தான் இருக்கு, 100% வந்து தான் 10% தான் increase ஆயிருக்கு. The dissolution process of ammonium nitrate is endothermic. The solubility increases steeply with increase in temperature. So here that is ammonium nitrate is a endothermic. What is meant by endothermic? Heat வந்து evolve பண்ணும். Endothermic na heat வந்து absorb பண்ணும் ammonium nitrate. So the solubility of this steeply with increase in the temperature. So அப்போ என்ன ஆகும், heat வந்து easy absorb பண்ண ammonium nitrate அதனுடைய temperature increase ஆக அதனுடைய solubility வந்து increase ஆகும். அதுதான் இந்த கிராஃப்ல கொடுத்திருக்க. அடுத்தது வந்து சீரிக் சல்ஃபேட் கீழே இருக்குது. the dissolution is exothermic. அப்போ என்ன ஆகும், எவ்வளோ ஹீட் ஆனாலும் அந்த ஹீட்டை வெளியில ஏற்றிட்டு அதனுடைய solubility என்ன ஆகும், solubility வந்து கம்மி ஆயிடும். So that is the another one, that is steric sulfate. But another one is calcium chloride is exothermic. Calcium chloride exothermic. The solubility increases moderately and increase in temperature. That is also significant residing the position of the equilibrium. So என்ன ஆகும், முதல்ல moderateல increase ஆயிட்டே இருக்கும், அதுக்கப்புறம் மறுபடியும் என்ன ஆகும், திருப்பி decrease ஆயிட்டு மறுபடியும் வந்து increase ஆகும். This is another one difference in the solubility of the temperature. Okay, so that's all about this solubility of the solute. This is the next we see the next class. Okay, thank you children.